Hey there, Algebra. We're going to do a new lesson today, lesson 11.2. Join me on page 684 of your book. That's where we'll be picking up. We're going to learn a new type of function today. That's rational functions. Rational functions look like this. They'll have y equals something being divided by x. Sometimes you can have a number being added or subtracted from the end. We'll talk about that too, but most of them look just like this. So today they're going to have you find what's called an excluded value. You can't have this bottom number, this denominator here, equals 0, right? Because you can't divide by 0. So whatever would make that bottom number 0 is called your excluded value. Okay, if there's just an x there, then the excluded value is 0. You can't have an x equals 0. So can you find the excluded value for each of these functions? Take a look. What can we not have this denominator be 0? So the excluded value is x equals 0. This one's going to be a little different though. Notice we have x plus 1 there, so we can't have that denominator be 0. So notice our excluded value for this one would be x equals negative 1, because if you put a negative 1 right there, we'd get 0 for our denominator, which you can't do, okay? What would this excluded value be? Notice if we put a negative 3 in for that x, we'd get negative 9, which plus 9 would equal 0. So x equals negative 3. So that's how you find your excluded value. That's one set of problems that you'll be working on today. Then they're going to talk about asymptotes. Kind of a funny name, but asymptotes are lines that your function graph approaches but never touches. Okay, so when you graph these rational functions today, it's going to make these mirrored loops like we had similar to our last set of problems, right? But there's going to be lines that this graph never fully crosses. So for instance, notice right here, this line right here, both of those pieces of the graph get really close to it, but they never fully touch it. That's an asymptote. This isn't a vertical asymptote right here. I just showed you the horizontal asymptote, right? Both of the lines get really close to that, but neither of them fully touch it, right? So those lines are called asymptotes. You have both a vertical asymptote right here and a horizontal line asymptote that the two graphs that you make, two parts of your graph, never fully touch. So we're going to show you how to easily find those today and why it's important to find those when you're doing these graphs. So to find the x or vertical asymptote, you decide whatever value you'd have to put in for x to make this bottom 0. Because remember, you're not allowed to have 0 in your denominator. So whatever value for x would make that 0 would be your vertical asymptote. So in this situation, our vertical asymptote is x equals negative 1. Okay? That'll be the vertical line that our graphs never quite touch. Okay? The horizontal asymptote or the y asymptote is really easy to find. It's right here. Whatever you're adding or subtracting at the end is considered your horizontal or your y asymptote. So y is 3. That would be our line going this way that our two parts of our graph never touch, our asymptote going horizontally. So can you identify the two asymptotes in each of these functions? Let's do this one. What's the x asymptote? Remember, that's the value that would make 0 down here, which we don't want. So in other words, negative 2, right? And what's the y asymptote? It's always this. So there you go. How about on this one? What's our x asymptote? Notice if I put a 3 here, I'd end up with 0 on the bottom, so that's what that is. And notice there's nothing here. So if there's nothing there, you just put 0 as your y asymptote, okay? So if there's no adding or subtracting going on at the end, your y asymptote is just 0. Okay, when you're graphing these rational functions, what you first want to do is they have you do it as part of your assignment. So here's number 10, by the way. This is your actual number 10. Join with me on this one. They first want you to identify your asymptotes because that's going to help you graph. I'll show you how. Notice our x asymptote, it would be 1, because if I put a 1 right here, right, I'd get 0 on the bottom, which we don't want, right? And then notice my y asymptote is here. So what you're going to do is you're going to put dotted lines on those spots. So if my x or my vertical asymptote is 1, I'm just going to put a dotted line here. I should never cross that line. I should get close to it, but never cross it, right? And my y asymptote is 2, so I'm going to put a dotted line on y equals 2. I should never cross that line either. That's going to help us graph. The other way our asymptotes are going to help us graph is we should choose numbers that are just for x that are just above and just below our x asymptote, because that'll help us get both sides of the graph, okay? So I'm going to make a nice big xy chart here, xy, and I'm going to want to choose some that are above that. How about 2, 3, 4? And that are below that. How about 0, negative 1, negative 2? Let's go with that just to start, and we'll see how good of a graph that gives us, okay? So let's put in these numbers. If I put in a 2 right here for x, I get 2 minus 1 is 1, so 3 divided by 1 is 3 plus 2 is 5, right? So I get 2, 5. Now if I put a 3 in for that value right there, 3 minus 1 is 2. So 3 divided by 2 is 3 halves, or 1 1/2 plus 2 is 3 1/2, right? And then if I put a 4 in right there, I'll do that real quick. That gives me 3. So 3 divided by 3 is 1 plus 2 is 3. Let's see if that gives us enough to graph this thing. Remember, we should never cross our asymptote lines. So 2, 5 is our first dot. So 2, 5, there it is. 3, 3 1/2 is our second dot, so about right there. And 4, 3 should be our third dot. And then I can use my asymptote lines. I know I'm going to get close to them, but never fully cross them to give a pretty accurate graph. So you see how I never fully cross my asymptote lines? Okay, now let's do the other one. If I put a 0 in for x into my equation, I would get -1, right? So 3 divided by -1 would be -3, plus 2 is -1. So 0, -1. Let's put -1 in there next. Here we go. I put -1 in there. -1, take away 1 more would be -2. So I get -1 1/2, right? Plus 2. So that would be what? Just positive 1/2, right? Now let's put a -2 into our equation. So if I slide a -2 right here, -2 take away 1 would be -3. 3 divided by -3 would be -1 plus 2 is 1. So that should give us enough dots to graph this thing. Let's find out. 0, -1. -1, positive 1/2. So about right there. And -2, 1. So we can see where this thing's curving, right? It's going to get really close to my asymptote lines on both sides, but never fully touch. And notice we end up with a mirrored image of what we had on the other side. So when you're graphing, first steps first, put your 2 asymptote lines, right? Just make dotted lines so you can kind of see them. Get a few dots on each side of your x asymptote, right? Do a few x values on each side. And then your asymptote lines will show you how quickly you need to bend your curves, because you're never going to fully touch those. So that makes it really easy to graph your 2 curves, and you should end up with a mirror on both sides. Hopefully that gets you off to a good start. If you have any questions or you get stuck, don't be afraid to contact me. Have a good day, guys.